Welcome to class. In the last video, we saw how to find the general solution of an nth order linear non-homogeneous equation by variation of parameters. And it took a lot of work. If you haven't seen that video, you're going to want to watch that before we do an example. All right, here is an example that we can use variation of parameters on. Notice this one is third order, and it would be rather challenging to do the method of undetermined coefficients on this problem, or an annihilator approach, because, well, you can't really annihilate the right-hand side at all, and messing around with all those sines and cosines trying to get it just right across three derivatives is going to start being taxing, right? And you're going to have a lot of linear algebra to do. So I want to avoid that if I can. I think variation of parameters might be the fastest way to find the general solution to this problem. Now, there are really just three key steps. The first step is the same across all of our methods. I need that complementary solution first. We need to find YC. Well, here my characteristic polynomial is lambda cubed plus lambda. When I set that equal to 0, it gives me that lambda should be 0 or plus or minus I. Now I can write the complementary solution as lambda 0 gives me c1 e to the 0x plus the conjugate pair plus or minus I gives me e to the real part, which is 0x, times c2 cosine of 1x plus c3 sine of 1x. There's my complementary solution. The second logical step I need here is to compute all of my Wronskians. And I use that term a little loosely here because there's really just one Wronskian of each of my fundamental solutions, but I need to build those W1, W2, and W3 for this problem. The Wronskian is, of course, the Wronskian of my fundamental solutions. Here that's the constant function, or 1, right? I've got C2 times cosine. I've got C3 times sine. This gives me the 3 by 3 determinant. 1 cosine of x, sine of x. Take derivatives. 0 negative sine of x, cosine of x. Take derivatives again. 0 negative cosine of x, negative sine of x. And wouldn't you know it, that's 1. Now, we didn't explicitly write the formulas out in the previous video for higher order w's, so let's do the first one together. The only thing I change when computing w1 is I'm going to just totally cancel out the first row with zeros, except in the very last spot, I'm going to plug in my right-hand side, which is tangent. I leave everything else the same, though. So I still have cosine of x, negative sine of x, negative cosine of x, and sine of x, cosine of x, negative sine of x. And wouldn't you know it, that's tangent. I'd encourage you to pause the video here, see if you can compute W2 and W3 on your own. I'll be right back. I'm going to clean it up and write them down. Doing these quickly in my head and definitely not off camera. W we found together to be 1. W1 we found together to be tangent of x. W2 and W3 hopefully you were able to find to be negative sine of x and negative cosine of x respectively. So now that I have all these Wronskians, I can find my variable parameters. I can find mu1, mu2, and mu3. by integrating them. Remember, mu 1, for example, is just the antiderivative of w1 over w dx. In this case, w1 is tangent, and w is just 1, so it's the antiderivative of tangent. And that is natural log of the absolute value of cosine of x. And I think I should have a negative on there. Yeah, or natural log of secant, whichever you prefer. Mu 2, similarly, is the antiderivative of w2 over w, or the antiderivative of negative sine, which is cosine. And then mu 3 is the antiderivative of negative cosine, which is sine. Negative sine, excuse me. That's all the info I need to write down the general solution, so let's write it. The general solution is that y of x is still my complementary solution plus my particular solution. The complementary solution we've already written down. It's c1 plus c2 cosine of x plus c3 sine of x. The particular solution follows the same format. It's just that instead of the c's, I use the mu's. So, plus, I have mu1 is natural log absolute value of secant of x. Fine, I'll cave. C2 is cosine. If I have cosine times cosine, that's cosine squared. And C3 is negative sine. If I have sine times negative sine, that's negative sine squared. So all 6 terms here, 3 from the complementary solution, 3 from the particular solution, make my general solution.